Anyway, I wish all of you are hearing me. Okay, good. Fine. Today we are going to talk about the core of civil engineering in your exam. Guys, when you are going to attempt such exam, they are examining your knowledge. They are not your experiences or your skills or project management skills or your personal skills, not required in this exam. Except one thing, your personal skills, how you are going to manage your exam time. This is very important. Okay, so your background for civil engineering should be what? Should be deep, moderate, fundamentals and principles. Let us see. So we'll start with this graph actually. This graph, it's data analysis. I notice that all of you as a civil engineering attend these courses and attend the exams. Most 85%, you can say 85% need to start from scratch. So why we start with civil with structure analysis? Why we start these particular topics? The first session in our Green International sessions, it will be structure analysis. Why? Because structure analysis, all of you forget how to solve the problems. What is the method of analysis? What does it mean bending moment diagram? The signs, positive, negative. What is the shear force, negative, positive? What is the normal force, positive, negative? All of you need to start from scratch. 85%, it's not all of you. I can say 15% have the background and have knowledge. Maybe they are working as structure analysis engineers, so they knew. But most of us, we are forget a lot of years back. So now we are going to go for refreshing, and we are going to fundamentals. I am going to give you the fundamentals and principles to solve any question coming or problems coming in structure analysis areas, which you are going to gain confidence, which you needed badly in your exam. Yes, you need it badly. Once the first question in your exam coming to you as a structure analysis in your screen, oh, nightmare, I am going to shock. No, you are not going to shock, because you are going step by step how to solve these problems. Let's start, guys. Structure analysis is about what? What is structure analysis about what? You have four main questions. Which one? What is a structure analysis? Number one. Number two, what are you as a civil engineer studied structure analysis? Why we study structure analysis? Okay. Number three, what are the knowledge areas should you focus on? So that's meaning structure analysis, guys, we can take it in 5 years. We are going to give it in 2 sessions, 6 hours. In 6 hours, how you are going to solve problems for structure analysis. Okay, so that's mean what? We focus in a particular point. We will see. So number 3 is what are the knowledge areas should you focus on? Number 4, what are the structure elements should you focus on? That's meaning knowledge, structure elements. Okay, let us go one by one. Any problems, guys? Please, if anything, just raise your hand or send a chat, and we are, Mr. Ravi will solve. Anyway, let us go for our first one. What is a structure analysis? Okay, the structure analysis is the determination of the effects of loads, effects of loads on a physical structures, effect of load in physical structure and their components. Okay, what does it mean? How many type of loads we have? Our major loads is dead load and the live load. All of us study this one from whatever in our college days. We are studying live loads and dead load. So how the effect of this live load and this dead load affect any structure system and they make it stable. That means what? We have, assume now, I'm going to go for another slides. We are going to do now the load of effect. Assume now you have a slab. Slab. This is a slab. Slab. This slab is 6 meter length, and you have which is 3 meter. You have loads here. You have loads, life load, walking in the slab. In your opinion, what is the root path for the load through this system as a slab, as I'm talking about the effect of loads on a structure system? So if you have multi-stories ground floor and 60 floor, and you are in the 60 floor building, you are living in the 60 floor building, and you are moving in the slab. This slab dimension is 6 meter and 3 meter. In your opinion, the load is going for what? The load is going in 2 directions or 1 direction? For sure, 100% we have 6 divided 3 equal 2. Okay, length divided width is equal to. That means what? The load is going in 2 directions. Any load, it will go in 2 directions. Good direction. This way and this way. This is one-way slab. So the effect of the load, we study the effect of the load. Effect of the load in the slab. Until reach where? Until you reach the ground floor in the foundation to the soil. So if even you are living in a floor number 60 floors, and you already have a flat 1 bedroom, this bedroom is 6 meter and 3 meter, or a hole 6 meter multiply 3 meter. Does it mean what? You know now the effect of the load going through 2 direction to the main beam, and the main beam to a column, until to reach to the next column and foundation level. This is why we study what is the structure analysis, the effect of the load. So that means what? You have to know the root path of loads. The root path of loads. How the loads, it will transfer from a particular element until to reach the ground floor. This is what we call it effect of loads on a structure system. Again, we'll come back to like 2-way slab and 1-way slab. So that means what? If L, I'm giving you a hint, if L over W equal 2 or more than 2, that means what? That this is 1-way slab. If L over W less or equal to less than 2, that means what? This is 2-way slab. You have a 1-way slab and 2-way slab. By the way, this one question on your exam, this is a way. One question on your exam is not a problem question, a theoretical question. So that's meaning what is the definition of 1-way slab and 2-way slab? You will know it now. Okay. To start to go for hours. That's meaning what? You need to know the effect of the load in a particular system until the load safely and reach to the ground floor. Let's go come back to our what is a structure system analysis? Structure analysis is the determination of the effects of loads on a physical structures and their component. What does it mean, their component? Might be a frame system, might be a truss system, might be a beam system, until beams like conventional structure, like consist of beams, slab beams, columns, or a particular warehouse like rafter and sheets and purlins and rafter until column until ground floor or truss system. That is their component. Now, what is the second question, guys? The second one is, why are you as a civil engineer study structure analysis? Structure analysis is important because it can evaluate whether a specific structure design will be able to withstand external and internal stresses and forces expected for the design. Okay, what does it mean, guys? This is another a big topics we can talk about it, but anyway, we'll start about equilibrium. We'll talk about equilibrium. We are talking about equilibrium equation, and we are going to talk about statically determinate structures, and we are going to talk about statically indeterminate structure. To get what? We talk about stresses withstand external and internal stresses. External stresses and internal stresses, what does it mean? Internal stress is coming from where? Coming from where? Coming from the internal forces. What is the internal forces? Internal forces is what? Is normal force? Hello?
Open the screen. Your screen is not seen. You are not seeing the screen. Presentation.
Okay, now?
Yes. Okay.
So now we'll come back again for the second one, guys. Sorry, the second one. The second question: why are you, as a civil engineer, study structure analysis? Structure analysis is important because it can evaluate whether a specific structure design will be able to withstand external and internal stresses and forces expected for the design. Loads, what type of loads our concern? Our concern is live load and dead load. Okay, there is wind load, there is a thermal load, there is what else? Earthquake loads. There is a lot of type of loads, but in our exams, guys, it will give you a dead load and live load. Okay. What is the withstand? Withstand with external and internal stresses. So what we are going to discuss today about equilibrium equation, statically determinate and statically indeterminate structures. Okay, let us go one by one. Withstand, equilibrium. If any force will let anybody move, that means what? This is not under equilibrium. If this body resists the external force and make balance with the internal forces and internal stresses, that means we call it the body under equilibrium state. So under equilibrium states, we are going to go back for share another. All of you, I will leave now. Okay, what does it mean? If you have a body, any body, rest on ground, and this body have force F1 and another force F2. We said this body is under equilibrium states. Means what? Means I have three equations to judge if this body is under equilibrium or no. All of you see the screen, guys? I saw some engineers asking questions. About of structure analysis. Anyway, now okay, guys, now okay. All of you see the screen now, guys? Okay, sorry. What does it mean when we say this body is under equilibrium? Means sigma x, the forces in x direction, it will be 0. Sigma y, all the forces in y direction should be 0. The third equation is sigma m moment at any point inside this body should be 0. If I have these three equations in any particular body, and this equation, all of them, sigma x is equal 0, sigma y is equal 0, sigma m is equal 0, I will say this again.
Screen is not appearing.
Cannot hear
Screen
you.
is not appearing.
Oh, I am already share. I already share. Share. I am sharing. Oh,
You're not seeing the
I
screen.
already share already. Now all of you share again.
Oh, okay. No.
I am sharing
Yeah,
already.
now we can see. Yes.
Right. Let us talk again. If we are calling now a body is under equilibrium, what does it mean under equilibrium? I have a particular body like this body. This exactly body I have now. I have a body not right now. This is a body what I'm talking about. And this body already have exposed to F1 as a force and F2 as another force. And this force is inclined with theta, and this is with alpha. Okay. And I said this body is under equilibrium state. If I am saying this body is under equilibrium state, I will say three equations should be 0. What is three equation? Equation number 1. Equation number 1. Sigma x equals 0. This is one condition. The second condition is sigma y. All the forces in y direction should be 0. Okay, I have sigma y, all of them should be 0. And the sigma m, any moment at any particular point should be 0. If I have these three equations equal 0, that means what? This body is under equilibrium. But how it's come? For sure, 100%. If I have force F1 and F2 exposed to this body, that's meaning there is a reaction here. 100%. We call it R, reaction. For every action, have a reaction. F1 and F2 is action. So that means what? R is a reaction. So the first equation should be what? Let us see. This is F sine theta, alpha. And here is F2, F1, F2 here, F2, F1 sine theta. يبقى the sigma y should be 0, means what? F1 sine theta should be F2 sine alpha. This is the first equation. Second equation in x direction. That means what here? F2 cosine alpha. And here is F. See the direction of the forces, see the direction? Sorry, this is wrong. This sigma x, sorry, this is wrong. This is wrong. This is wrong equation. Sorry. I will make it in x direction first. F1 cosine theta. Sigma x equal 0 means what? Means F1 cosine theta should be equal F2 cosine alpha. This is the first equation. What about second equation? Second equation, sigma y equal 0 means what? Means R should be equal F1 sine theta plus F2 sine alpha. This is the second equation. And third equation, if what? All the forces giving a moment in particular moment should be, the summation of this moment should be 0. some of these forces giving negative moment and some of them giving positive moment. Positive moment plus negative moment together should be 0. This is, we call it equilibrium. Equilibrium mean what? Mean against sliding, the body cannot slide. Against overturning, the body cannot overturning. Against uplifting, the body cannot be uplifting. In your exam, they are going to give you a question related to one of this type of, again, questions, and let us see. One type of equilibrium means sometimes he will give you uplift. What's a combination of a particular forces giving a particular unequilibrium state like uplifting, overturning, or slide. This is, I'm giving you now, what does it mean equilibrium and what does it mean equilibrium equation? We have equilibrium equation, 3 equations. We have equilibrium states, means all the equations should be 0. Okay, let us go for second. Let us go for another part from structure analysis. We'll go for another one. Let us erase this one. Erase. I will erase, guys, 1 minute, please. Type. For our structure system, we have 3 particular areas: beams, trusses, and frames. What type is in? Then we are we have a particular type of beams. What does it mean, beams? This is a beam. What does it mean? Okay. This is, we call it simply supported beam. Now, what does it mean, this figure? This figure, we call it what? We call it bent support or hinged support. What about this one? This we call it roller support. Okay, so this is a standard like what? Standard figures or standard systems that we are defining, that putting a particular supports to define a particular system. Like مثلا, we have a simply support. This is a simply supported beam, and this supported beams that have 3 reaction and have 3 equation of equilibrium. That's meaning we call it is under equilibrium or not. We are using the 3 equation of equilibrium. Okay, anyway, the support is a support. For each support have a reaction due to external load. Any external load, we have reaction. B, we have here R1 and R2 reaction, and we have R3. R3 is what? Perpendicular to the movement of the roller support. Always perpendicular to the movement plane. We have here 2 reaction. Yes, we have 2 reaction in X direction and R direction. So when you study the equilibrium, we consider it as under equilibrium state should be what? should be sigma x equal 0, sigma y equal 0, and sigma moment at any point equal 0, at any point of the beam. Okay. Okay, let us go for our slides. Share, stop sharing, stop sharing, stop sharing, share. All of you now, why are you as a civil engineer study structure analysis? Structure analysis is important because it can evaluate whether a specific structure design will be able to withstand external and internal stresses and forces expected for the design. This is what we call. Once we are any system apply the forces like life load or dead load, this load is affecting a particular beam, slab, column. And we are going to study the equilibrium. We'll see the equilibrium, or this body is under equilibrium or not under equilibrium. There is a particular methods, like we are going to have reactions, collecting all the analysis, and we get all the reaction. From the reaction, we are going to draw the shear force diagram, normal force diagram, and the moment diagram. In the end, we are going to collect the internal forces, which is a shear force, normal force, moment, and after that we will calculate the internal stress. From the internal stresses, we take all these values, we design the section, how many steel areas, what is the section type, how the dimension of the section. All of this one is related to structure analysis knowledge. Let us go for what are the knowledge areas I should focus on it? Exactly. What is that? Exactly what I am going to focus on it. Shear force, normal forces, and bending moment forces. Yes. Give a shear force. How I am going to define and calculate and determine estimate the shear force. How I am going to estimate the normal force and bending moment force. Number 2, shear forces, normal forces, and moment diagrams. How I am going to draw the diagrams. What is minus, what is positive diagrams. This in your exam, it will not give you particular draw the bending moment or draw the shear force. No, it will give you a particular problems and asking you about the moment at this point, the shear force at this point, the value of the reaction. So if you don't know how to use this methods, how you are going to calculate the shear force, how you are going to draw the normal force, how you are going to draw the bending moment force, bending moment diagrams, you should know how in a simple way, which we are going to give you in the classes, and I will give you example right now. Number 3, statically determinate and statically indeterminate structure elements. What is the difference between them? Stability of elements, of structure elements, we'll discuss about it, and deflection and slope of structure elements. There is a particular areas we are going to discuss about deflection, especially for trusses, which is common question in your exam. I will give a lot of examples related to this one in our session, but I'm just giving an introduction for our webinar today. I will give what are the structure elements should I focus on? Beams, trusses, and frames. Beams, trusses, frames. Okay. What type of beams? What type of beams? We have what? We have cantilever, we have simply supported beam, we have overhanging beams, and we have continuous beams, and we have fixed ended, and we have cantilever simply supported. Very good. Let us go for our, I will give example now. What does it mean? Simply supported, we have two support, two support. Continuous, we have many supports, 1, 2, 3, 4. Okay. What does it mean, guys? How many reaction we have in figure D? How many reaction in figure D? This figure is indicate for roller support. That means what? That means we have one reaction. We have one reaction in this support D. In support, this support, and we have another reaction in this support. That's meaning 1, 2 now, and we have another reaction. Does it mean 3 reaction now? And we have 2 reaction in this support because this is a hinged support. That means what? We have how many reactions then? And 1, 2, 3, 4, 5. This continuous beam have 5 reaction, 5 unknowns. I need to calculate them to get all the internal forces. This beam have 5 reaction. Okay, what about the simply supported beam? This simply supported beam. This simply supported beam have 2 reaction, and 1 reaction, 2 reaction, and 3rd reaction. That means what? We have in this simply supported, I have 3 unknowns. 3 unknowns. I need to estimate these 3 unknowns to get all the internal forces. So I will get the internal, once I get the internal forces, I will get all the internal stresses. From this internal stresses, I will check, are this section, it will be stand with the external force or not. I'm going to design the section, the size of section, the area of steel, what type of concrete or steel, whatever is suitable for our design. Cantilever, this cantilever fixed end in this end. Fixed ends means what? I have 3 unknowns, 3 reactions: sigma x, sigma y, and the moment. Okay, what about this overhanging? Overhanging, I have 2. This overhanging, I have 2 reactions because this is roller support, and this is the second roller support. That means I have 1, 2. So I have only 2 reaction. Okay, how? What about LE, fixed ended? Fixed ended, I have 3 reaction in this end and 3 reaction in this end. That's meaning I have 6 reaction unknowns. Okay, here in F, I have cantilever simply supported. That means what? I have 3 reaction plus 1 reaction. That's meaning I have 4 unknowns. Question the answers. Why fixed end of beams? Fixed end of beams, yes, a lot of fixed end of the beam. You have a rafter fixed in frames, concrete frames, or shear wall. This shear wall fixed with the beam. That's meaning what? This is a beam. We call it fixed ended beam. Fixed ended. Why fixed end of beams? Yes. All the rafter which you already bolted to a shear wall, we call it a fixed end beam. Okay? Let us go for our again. We'll go for particular examples for each one. Erase. Let us go for question 2. I need video. Sir. Okay, so you don't see me. I need video. You don't see now, all of you. Type again. I will stop sharing. Share again with share. All of you guys now. We fix end. All of you now, okay? Okay, I'm human tired. Okay, you almost 45 minutes. I will finish. 45 minutes. I will finish. 45 minutes, guys. We will finish. Just I will give example how you are going to determine what is the indeterminate and what is the determinate. Okay, let us go for one example. When I said determinate, what does it mean? If you have a beam like that, this is roller support, and this is hinged support. I have load, a particular load, uniform load, live or dead, whatever. And you have concentrated load, live or dead. And you have reaction. How many reaction you have here? Adi 1, 2, يبقى this B, and this is B, ton or Newton or pound per meter. This is, we call it pound, feet. And this is B1 and this is B2. And you have here R1, R2, and you have perpendicular reaction, we call it R3. How many reaction, guys? I have 3 reaction. You have 3 unknowns. 3 unknowns. How many equation of equilibrium? I have equation of equilibrium equals 3. Sigma x, sigma y, and sigma moment equals 0. In this case, I call this beam is statically determinate because I have the 3 equation, sigma x equals 0, sigma y is equal 0, and sigma moment at any point in the beam is equal 0. These 3 equation equal 3 unknowns. I have the 3 unknowns. Okay, this is a definition of how you are going to define this element or this structure system or this structure element is statically determinate or statically indeterminate. Determinate, indeterminate. This is statically determinate. Okay. What about statically indeterminate? Let us have the same beam. This is uniform load. This is B2, pound per feet. And we have here B1. How many reaction I have here? At the R1, R2, and they have R3 and R4. How many unknowns then? At the 1, 2, 3, 4. You have 4 unknowns. How many equation of equilibrium? 3. Okay, 3 minus 4 is 1. As this element, this structure system element is statically indeterminate first degree. First degree. Now it's we call it statically indeterminate first degree. Okay, so another example. Fixed end beam. Fixed end beam. Fixed end beam. This is fixed. This is an indication of fixed end. And you have B1. B1. And you have one particular length, whatever the length. L, feet, meter, whatever. How many reaction I have here in fixed end? I have one X, I have Y, and I have moment. This force, it will be, give me a moment, or X here is equal 0 because there is no a particular horizontal force, but I have value. 0 is value. In Y direction, I have reaction and I have moment. So how many unknowns here? I have 3 unknowns. 3 unknowns. 3 equation of equilibrium. That's meaning what? This is statically determinate 0. But this system is statically determinate. So what about this system? Same. This is hinged, and this is fixed end. And you have uniform load, and concentrated load, B1, B2, bound feet, and you have A, support A, fixed end, and B. Okay, what is the problem now, guys? It's planned until, okay, guys, okay, it's planned 2 hours. Okay, 2 hours, it will be, don't worry. We will go for 9:30. Don't worry. We'll give a lot of examples now. Okay, so we have here how many reaction, guys? I have here. I have one reaction, XA. I have YA. And I have moment A. And I have YB. And I have XA. How many unknowns now? I have 1, 2, 3, 4, and 5. You have unknowns now, 5 unknowns. Equation of equilibrium, 3. 3 minus 5, 2. That means what? This system, structure system or element, is statically indeterminate second degree. Now, how can I define the determination state? By equation of equilibrium and unknowns. I will calculate and estimate the unknowns, how many unknowns, and I have the 3 equation of equilibrium. And in the end, I will determine the statically determinate which degree, indeterminate, and if it's statically determinate, I can solve the question easily. In your exam, he will never give you equations indeterminate. Again, he will never give you equations is indeterminate. Okay, so that means what? He will give you all the problems which statically determinate type. In this case, how if in your exam, coming in your exam, he will give you another hint or another help. He will give you hinge here and another hinge here. What does it mean, hinge? Hinge is slice. We call it hinge. That means what? Sigma moment at this point, A, B, C, D. Sigma moment at C equals 0. Sigma moment at D is equal 0. I have plus here is 2 equations. That's meaning 5 equation now I have. 5 minus 5 is equal 0. That means this system now is statically determinate. Okay, guys? So slowly, I am giving everything now, but in our class, inshallah, we'll give it slowly, and we'll give example for everything. I will give another example for how to solve, what is the mean load and reaction, and what is the moment, negative, positive, shear force negative, positive, and normal force negative, positive, and we'll see solve one questions now. Assume you have a beam like that. Newton external load. This we call it external load. We have internal load. Yes. What is the internal load? I will calculate it now. So if this what we call it external load, what about the internal load? Let's wait. We'll see how to determine all the internal load. But this is A and this is B. Six meter and 2 meters. I told you now, give me all the internal load and draw the diagrams for the internal load. Internal load, when I'm telling about internal load, again, it's minimized. Change the main script, please. Okay, again, I will share it. Okay, stop sharing now. I will stop sharing again. All of you now, it's shared again. I don't know what's happening, but anyway, I share it again. So I have now assembly supported beam. This is assembly supported beam. Okay, guys. Okay. Very good. Now, I have assembly supported beam. This assembly supported beam have exposed to external load 10 Newton. This is a external load. This is the external load I am talking about. This one, external load. And I need to, all of us, to calculate the internal loads. What does it mean internal loads? Internal loads, which is shear, normal, and the moment. But before to calculate and estimate and determine the external load, can we make the questions and answer later, please? Okay. We need to focus, and all that I will give a particular time for question and answer. Let us focus now how to solve your question in your exam. First, this is very simple question, and we have assembly supported beam. This assembly supported beam have external load, and I told you now calculate for me all the internal loads. Guys. Before you are going to draw the internal loads, you are going to, first you have to get all the reaction. How many reaction I have? I have it's not working. Anyway, I have YA, XA, and YB. I have 3 reactions. 1, 2, and 3. When I said the equation of equilibrium means what? For sure 100%. If this beam will move, that's meaning this structure system is not stable. And when I said stable, we have the assumption as a standard that the equation, the 3 equation, which is what? Sigma x equals 0. That means what? Sigma. That means XA should be what? 0. Why 0? Because there is no any horizontal forces here. But if I will put a force here, like for example, 2 Newton, that means what? XA equal 2 Newton. Why? To make balance. The direction of XA in this direction because the force in B in this direction. See guys, in this direction. So for sure 100% to make balance opposite to it as a reaction, you are in this direction. Again, question and answer. Please, you can please solve this problem. Minimize again. Okay, I will share again. I don't know what's going on in the sharing, but I will share it again. I will share it again. Share it again. All of you, please. Okay, now I believe all of you have the screen with me now. I will make it more bigger. Okay, now. Okay, let us see. So now, again, I will tell, we have assembly supported beam. This is assembly supported beam, AB beams. We have AB assembly supported beam. This assembly supported beam have exposed to external load, which is downwards load, 10 Newton. And we have horizontal load, which is 2 Newton, acting on B in the B roller support. So we have 3 equations. This 3 equation is equal. This 3 equation, I have sigma x is equal 0, sigma y is equal 0, and sigma moment. The first equation I calculate already XA. To calculate YA, I want YA. How I'm going to calculate YA? I will use the equation of sigma moment at any point is equal, at any point I will take it at point B. يبقى sigma moment at B should be 0. يبقى I will calculate YA multiply 8, YA force multiply 8, يبقى moment. Force multiply distance, I call it moment. YA plus 8, this giving me positive moment. Positive moment, I will tell you how to define the positive and the negative soon now. And this force 10 give me a negative moment on B, which is minus 10 multiply 2 equal 0. Yes, I have only now, if I'm going to have the moment at this point, اللي هي B, يبقى ال YA multiply 6 plus 2 is equal 8, minus, plus here is YA plus. I will tell you how to define plus minus. And I have minus 10 multiply 2 equal 0. That means what? In YA equal 20 over 8 equal what? Equal 5 over 4, 1.2. 5 over 4, 1.2. 2 لا is equal, sorry, 2.5. Two 0.5 Newton. يبقى ال YA here equal 2.5 Newton. يبقى second equation now I get moment at point B. This is the second equation. This is the first equation. The third equation is sigma y equals 0. Means what? Means Ly A plus Y B equal should be equal 10. Very good. Equal 10. I have Ly A is equal to 2.5. That's meaning what? Ly B equal 10 minus 2.5. That means what? Equal 7.5. Now LYB equal 7.5 Newton. Okay, guys? Okay. Now we get all the reaction. Let us get all the internal forces. Now I get the reaction. I will draw a very nice diagram now. We call it free body diagram. So now your free body diagram is like that. You have a body. I have force here equal 2.5. And I have another force here equal to. And they have another external force is equal 10. And they have reaction here, external force 2. And they have reaction here is 7.5. Now I get all the external force and reaction due to this external force. I will draw the internal forces. Let us start number 1. Normal force diagram. Normal force diagram is tension or compression. This is my free body diagram, and I have to both is compress any section here. If you get any section here, section 1, consider this section is a rectangular or square section. This force is perpendicular to the section. Perpendicular means this section is press. Okay, this diagram, this internal forces, negative or positive? This diagram is negative because this is compression. This is negative compression. 2, any section for this beam is exposed to internal forces called, how much is internal force? Minus 2 Newton. Any section, section 2 have 2 negative 2 Newton as a compression force. This is the internal force. What about question and answer? How do you draw a deflection shape of a beam? Okay, guys, I am talking now. Later on, we'll discuss the deflection beam. I will give it in the end of the session. Okay, I will give it now. We are talking now about internal force. Anyway, the deflection, I will here, if you have a beam, and this beam, no problem, we are having as an introduction now. This beam have external load like V1, the deflection, it will be go in this direction. It will be deflected in this shape. And this is the slope, and this is the elongation. Assume this is uniform load covering all the beam. This beam deflected in parabola curve. It will take this direction. The maximum deflection coming where? Coming in the middle of the. This is the deflection. and this is the theta. This is the slope of the deflection. Okay, guys, this is, we'll call it, if you have a concentrated load and if you have a uniform load. For each deflection, have a formula, and we are going to discuss about this one, inshallah, in our session once you are registered and at our class. So now this is a slope and deflection. I'm talking now about normal force. Normal force, this is a normal force diagram. We call it normal force diagram. What about shear force diagram? Shear force diagram is different. Shear force diagram, I am going to draw the shear force diagram. Always, guys, always we start from the left hand side. We start from the left hand side. Where is your left hand side? We left hand side here. So we have force here. This is the first force in my left hand side. This force telling me up. Up. So now up 2.5. Straight until the force giving me 10. This is 2.5 until me down. That means here is 7.5. Straight until the reaction tell me 7.45 up 0. Here 0 shear. This is the zero shear point in a section underneath the concentrated load. This is a section. I have the section here. This is a section. I have zero shear force under this concentrated load in a particular point. We call it neutral axis. Okay, this is a shear force diagram. Here is positive. As a science now, if the shear force in the left hand side up means what? This is a section now. Here is your section, and the force in the left hand side up, this is positive. In the right hand down, it's negative. In the left hand side, right hand side, left hand side, right hand side. Where is your left hand side? Left hand side here. So that's meaning all this one, all this area, giving me a shear, positive shear forces. Okay. If you calculate the areas, the area, it will give you moment, but I'm not, don't confuse yourself right now. We will discuss this one slowly in our class. How did you draw the deflected act? Okay. I answered. What about this area? This area giving me negative. That means here I have a negative. All this one is negative. Shear force. If I here negative and here positive. Now I get all the sections, all the internal forces related to shear and normal. Any section now I can. This section, for example, this section now, give me the internal forces, shear and the normal force. This section 3. But this section have what? Go down. I have normal force 2 Newton, negative compression, and I have negative shears. Means what? Section going down with force equal 7.5 Newton. From the normal force, I will calculate the normal stresses. From the shear stress force, I am going to calculate the shear stresses, which I need them to study the deformation of the section. And I will, from these values, I am going to calculate the area of steel, the section's dimension, and all the particular properties of the section. What about bending moment? Bending moment diagram, it will be, let us enjoy it, and this is really nice diagram, and we'll discuss about it now. Let us, our free body diagram, draw it, and we'll discuss about how you are going to define the section, the moment negative and positive. Again, my free body diagram. I have here 2.5 Newton, I have here 2 Newton, and I have here 10 Newton, and I have here 2 Newton, and I have here 7.5. I need all of you to draw normal bending moment diagram. Okay. Add point here, far away from this reaction with equal 3 meters. Calculate for me the moment here. This point is A, B, C. This C is far away from this support with 3 meters. So I will, this is the point, I have reaction 2.5, يبقى 2.5 multiply 3. This is the moment. I am calculated from the left hand side. I'm going to, this is the left hand side, this is the left hand side, this is the left hand side in this direction. So 2.5 multiply 3 is equal 7.5. Negative or positive, we'll discuss it about it. This is 7.5. In this point, I have this value of moment. We call it here $7.5. Let us calculate it from the right hand side, because sigma moment at this point should be 0. The right hand side should be the same as the left hand side. From the right hand side, what we have here, 7.5 multiply distance, which is already now 2, this is 8, 8 minus 3 is equal 5, as 7.5 multiply 5, this is positive moment, minus a 10, multiply what? A 10, and this is already 6, minus 3, you add 10, multiply 3 equal, sure 100% should it equal 7.5 positive. I will show you how you are going to calculate the moment now is equal 7.5 multiplies 5 is equal 37.5 minus 30 is equal 7.5. How we are saying 7, that's mean what? The moment here is positive. Why positive? Okay, I will tell you how you are going to, what is your technique to define positive and negative moment. You have a beam like that. This is your beam. And this beam is have this section. A and B. Okay, right. And you have uniform load. Due to this load, what's your opinion about the deformation? It will be this beam what? This beam, it will take this shape. So, it will take this shape. Okay, come in the middle of the beam. In the upper fiber here, the fiber here in compression or tension, due to this load, this beam, it will bend in this direction. And I have here reaction R1 and I have reaction R2. So in lower fiber here is tension. Lower fiber coming here is tension. Upper fiber here is compression. Our tension, see the moment here in this direction. If the force giving me a moment, it will cause a tension in lower fiber. That's meaning what? The moment now, the force, it will generate positive moment. Positive moment. Another reaction here, this reaction, it will give you again tension in lower. Where is the tail of arrow? This is the tail of the arrow. Here. Where is the tail of the arrow? Tail of the arrow. That means what? Positive. Because it will cause in the lower fiber in a particular section in tension. Okay. That means what here? See, this is upper fiber is compression. Any force it will generate in lower fiber tension side, it will be in a tension mode. That's meaning what? This force is positive. Go for another beam. Opposite to this beam, you have here you have another beam, the same beam, but the force, the same beam here, and is this same beam, but the force is in this direction. In this direction means what? The reaction in this direction and the reaction in this direction. R1, R2. What does it mean? Mean this beam, it will be bent in this direction. This is the reaction and this is the reaction. In upper fiber here is tension now. Lower fiber is a compression. That means what? That means this reaction, it will make moment at this point is negative because tension upper fiber. Tension upper fiber, lower fiber. That means see the tension upper, see? Here. See that? Where is the tail of the arrow? This is the tail of the arrow. And here this force, layer reaction. Reaction is a force. Reaction is giving me a negative moment because where is the tail of the arrow? Tension upper fiber. See? You by any force will give me upper fiber in a tension mode, that's meaning negative. I will give you example for tension in upper fiber for a fixed end beam cantilever. Let's go. Cantilever, let us draw the bending moment for cantilever. You have a cantilever. This is a cantilever. Fix end in this direction, and you fix end A and B, free end, and you have force here equal 10 Newton. And you have here 4 meters. Okay. You have now, how many reactions we have here? And we have XA, YA, and the moment. See my hand? Moment. The force giving moment in this direction. Yes or not? Yes. This is a moment now. It's action moment. what is the reaction moment it will make zero with this action? For sure, 100% it will be in this direction. Because 10 multiplied 4 is 40. Reaction of this moment should be in other direction because of them should be zero. يبقى in this direction 40. Okay. Both of them giving you tension in upper fiber. Where is the tail? At the tail. At the tail. Means what? This is negative moment. How to draw it? Very simple. Moment negative, we have two schools. French schools and British schools. I believe all of you follow British schools, which is negative down, but I am drawing the negative up here, and I will give the sign negative 40 Newton meter. This is how you draw the negative moment diagram. Okay. Why I draw the negative moment up and the positive moment down, which all of you, as especially is in India, in the India schools, are giving negative down and the positive up. Because the distribution of the steel, we put it in direction of the tension. So we put up because in any particular beams, especially if you have beams, continuous beam like that, this is a continuous beam due to a particular load, the negative moment always in here. This is a negative moment. See guys, this is a positive here, down, and negative here. And we put the main steel in the direction. Where is the moment area, side? This is the moment side. We put the steel here. This is the main steel, and the main steel bottom down here. Okay, guys. Later on, we'll talk about enough for beams. Let us talk for frames. Because we still have frames and trusses. I wish I am giving a particular areas, but inshallah we will give it in enough. Frames, we are going to have plane frames. That's meaning this is a plane frames. What is the difference between frames and beams? Connection. This is a connection. You have A, B, C, and you have here external load with your 10 Newton, and you have 4 meter and 4 meter. Main plane frame, it's meaning in XY direction. The load in XY direction only. X direction, Y direction. In particular, if you have X direction, this is a 2 Newton. Okay, so now, what is the difference between, I said, the connection. I have LB is, we call it a rigid connection. What does it mean, rigid connection? In rigid connection, if you cut a segment A, B, means I have 3 reaction internal forces, it will be appear. X, B, Y, B, and moment, M. You got X, Y, moment. Once you cut the segment, to make balance and equilibrium for this segment in AB, I'm going to have the 3 components of the internal forces. It will be appears to make this segment balance. That means what? Means first you are going to calculate the reaction. Let us calculate the reaction. I will show you how, what does it mean there. The internal forces at joint, rigid joint. Let us calculate first the reaction. The reaction here is YC, XC, and the moment. Let us see the moment here. We have two different type of moment. Add one, see guys, coming here, one, make tension in upper fiber, here, upper fiber, see, make tension, that's meaning this is negative. 10 multiply 4. And they have another moment in this direction, see, opposite. 2, make lower fiber in tension, that's meaning negative. Here is 2 plus 2 multiply 4. The moment here is equal what? If this moment in this direction, that's meaning this moment it will be in this direction. See? The result is what? Minus 40 plus 8. This is 32 minus 32 Newton meter. Okay, how to solve this type of frames? Okay, here you have the first segment, cut the first segment. Add the first segment. You have here what? You have 2 Newton and you have 10 Newton. And what is the X here? X should be 2. صح? Yes. And Y is equal what? Is equal 10. And the moment, this force make moment in this direction. So to make reaction and make stable, that is the moment. You tension upper fiber, right? Yes, because the upper fiber here, the tail in upper fiber here. This is 10 multiply 4 minus 40. Here is minus 40. Okay, fine. Go for the other segment. This is segment A, B. The other segment, add my other segment. If it's 10 upper, here is 10. 10 up, 10 down. Because if you put them together, 0. Okay. And X in this direction, that's meaning in X in this direction. If I 2, put them, add 0. So, okay. The moment in this direction, other moment in this direction. Minus 40. Yes, tension upper fiber. Yes, still tension in upper fiber. Add minus 40 minus 40. Put them together, disappear. Because it should be balanced. Okay, very good. In the end, I have here already what? I have 10, as I calculated, 10. And this should be as a 10. And 2. Yes. Because sigma x add 2, sigma y add 10, moment is 30 minus 32, yes, add 10 here, correct, and they have the x in this direction, see, balance, already calculated, you got 10 add 2, 2, sigma x is equal 0, yes, correct, sigma y is equal 0, add 10, what is 10? 0, and the moment, I have minus 40 here, and I have 32 here, how it's come? Yes, 32. Let us calculate it. Come here, at this point. I have 40 minus 40 minus 40 minus 40. Reaction of it at the minus 40. Plus here 2, make in this direction 2, 2, 2. Coming here in this section, make 2, 2 multiply 4, 8. يبقى plus, يبقى 40 minus 40 plus 8 يبقى equal minus 30. This is how the way we are dealing with what? We are dealing with the frames. In the end, you are going to draw the shear force diagram and the normal force diagram for each, for the entire frames. And for particular section, there is a normal force, shear force, and the moment. We will know about this one. Let us go for trusses. Trusses, there is no shear, there is no moment, only internal forces, which is a axial forces. We call it axial force. Any truss consists of joint. Add a joint. Member. Joint. Member. Joint. Joint to joint, member. Joint to joint, member. Support. Okay. This external load B, whatever B, ton or Newton or kips or pound or Newton or whatever. Right. In trusses, we have two methods to solve any equation related to trusses. And what else? Yes, sir, we have two methods and two rules. Okay, what is the two methods and what is the two rules? First, let us see, are this truss stable or not stable? We have to define first, are this truss stable or not stable? Okay, let us see. I'm not talking about statically determinate or not statically determinate or no, statically indeterminate. First of all, this is statically determinate. Why statically determinate? Because I have now at the one reaction, R1, and they have two reaction, R2 and R3. This is the three reaction, and the 1, 2, 3 reaction. And I have three equation of equilibrium, and the equation of equilibrium equal 3. And they have unknowns equal 3. This truss is what is statically determinate. I am talking about stability of the truss. Stability of the truss, let us see now another equation. What does it mean? If you have joint, how many joint are the one? Joint. Two joint, second joint. Third joint, fourth joint. Okay, 2 multiply joint, 2 multiply joints equal 8. Okay, equal 8. Let us see the members. How many members? 1, 2, 3, 4, 5. 5 members. Everybody, 5 members plus 3 unknowns. How many unknowns? 3 equal 8. Okay. This truss is stable. What is the equation then? 2 multiply joints should be equal unknowns plus total members. If you have the equation is not this part is not equal this part, that's meaning this truss is not stable. If 2 joint, 2 multiply total number of joint is equal unknowns multiply total members plus, unknowns plus total number of members. This means what? This truss is what is stable. Number 1. Number 2, how you are going to define the forces in tension mode or compression mode. Means what? Let us see an example. There's a lot of techniques, guys, to study structures, but this is a simplest way and techniques to make it memorize and easy to solve any type of question. With exercise makes perfect, which we are going to give you a lot of exercise from previous exams, and we are going to give you a particular homework as well You are going to solve it, and you are going to be, inshallah, in a good mood. Let us see. You have a joint, and you have member and joint. This joint have force in this direction, 10. And for sure, 100% to make this stable and equilibrium, this should be 10. 10 Newton, 10 Newton. 10 Newton. Okay. Cut in this there, cut here, section 1, and the cut here, section 2. Take the balance of the joint, method of joint. This joint to make stable, what does it mean? To make stable, for sure 100% sigma y is equal 0, that means what? This is 10. 10 upward, 10 downward, 0. Sigma y here equal 0. Okay. Here in this joint, take this joint. Means what? The force for sure 100% is 10, because this joint, I'm talking about this joint now, joint A, joint B, joint A, balance, sigma y is equal 0, the force in this direction, yes. And here, joint B, sigma y is equal 0, okay, that means this direction. So, what type of internal force for this member? Have internal force, tension or compression? I need to see all of your answer now. Give it to me in my chat. Give it to me now. Tension or compression? Let us see, guys. All of you. Tension or compression in the internal force? Let me the first one. Okay. Tension. No compression. Why compression? Let us see the external force. The external force make in this direction. See, this is external force. Make compression in the member. But the indicator of the forces, okay, make compression. Okay, how you are going to define it? Put your finger here. Put your finger here in the joint. I am putting my finger here in the joint now. This force compress or tension your finger, this compress. That means the internal forces here is compression. Make the other opposite case. Opposite case, I have a joint, member, and I have forces in this direction. See, tension. This 10 Newton. And here is 10. Of course, 100%, this member have tension, internal tension force. But how you are going to define it? Let us take section here, section here, and section here, and section here. Method of joint, joint A. Make balance now, sigma y is equal 0, that means what here, see? This is the force, 10, because sigma y should be 0. And here is joint B, sigma y is equal 0. See, the force here is 10. This force is 10, tension positive. Why? Put your finger here. This force pulling or press, pulling. That means what? How you are going to define negative and positive internal forces? By this technique. Very simple technique, very easy, and you can easily let us see what. Okay, later on we'll see, and easily you can define. So now we have how you are going to define the internal force for the members by this technique, guys. If you put your finger on the joint, if the force, internal force, this internal force, guys. This internal force, this is the internal force, this external force. I'm talking about this external force. This is external force. Here is the internal force. If the internal force were pulling your finger, in this case, that's meaning tension. If this force is press, that's meaning compression. This is compression minus, and this tension. I believe it's very easy, and you can solve. Let us have a particular example for a truss. Very simple truss. You have a joint, another joint, member, ادي member, joint. يبقى A, B, C, and D. Member, and support. Another support, roller support, hinged support. Three feet. And you have the external force equal, here is what equal, you can say 10, you can say 10 kips, okay, no problem, kips. And you need to determine all and calculate all the internal force in the internal in the members. How many members you have? Let us see how many members you have. 1, 2, 3, 4 members. Okay, you 2, 3 members plus unknown, 4 members. The equation is telling you total members plus unknowns. How many unknowns? Add 1 unknown, Y, D. Second unknown is X, C. And the third unknown is Y, C. يبقى 3 unknowns, هذه 3 unknowns plus 4 equal what? Equal 7. Okay. What is the other part of the equation? 2 joint multiply total joint multiply 2. 4 joint. ادي 1 2 3 4. يبقى 4 multiply 2 equal 8. Allah, this is the equation is not matching. Means what? This is not stable. This truss for sure 100% will fly with the wind. To make it stable, you have to put here another member. Now it's stable. Okay, that now is 5. But this is 8. This stable. Statically determinate, because equation of equilibrium 3, equation of equilibrium equals 3, and I have unknowns equal 3. You have 3 equals 3, that means what? Statically determinate. Stable. Okay, first you get the reaction. You have to get the reaction for any particular structure analysis question. You have, unless you already have different problems. This is 10. Gives. The reaction here, XC is equal what? X is equal 10, because should be 0. 10 in this direction, opposite to it in this direction. Okay. I need to calculate YD. YD. This is D. and this is, I need to calculate. YD, I will take the moment at C, should be 0. يبقى sigma moment at C equals 0 means what? YD in this direction, tension down, tension down, Y D multiply 3 should be equal tension up here, this force 10, opposite to it, that's meaning this YD here, opposite to it should be different now. If this moment take you like that, يبقى should be the reaction opposite this direction, because to make moment opposite to it. يبقى here is equal 10 multiply 3, يبقى 3 multiply 3 is equal YD equal 10. يبقى this is equal 10 downwards. Sigma y is equal 0, that's meaning upward is equal 10. Now I can draw the free body diagram for the truss, and from this free body diagram I will use the method of joint. The truss, my truss is like that. I have force here 10. I have force here 10. And I have member. And I have force here is 10. And I have here 10. Yes, balance now. 10 in X direction, 10, 10. In Y direction, 10, 10. I need to calculate the internal force. I will take the method of joint A, B, C, D. I will take the first joint, very simple joint, this A. يبقى joint A, add joint A. Have joint and they have member and another member. This is joint, method of joint. So this force here, once you cut the member, there is for sure 100% there is internal force F, A, B. And you cut here, you have F, A, D. And you have external force in this direction, we call it 10. Okay. You have two equations, sigma x equals 0 and sigma y is equal 0 to make balance. يبقى sigma x is equal 0 means what? Means F A B equal 10. Which direction? In this direction. Put your finger here. Put your finger here. This force compress. يبقى negative 10. Type sigma y. يبقى this is negative compression C. Take sigma y is equal 0. Sigma y is equal 0. Yes, 0. يبقى FAD equal 0. There is no any vertical force or inclined force or whatever in y direction. يبقى for sure this force is equal 0. This force is equal 0. And this force is equal compression minus 10. See now, by method of joint, you can what? You can calculate all the internal force. I give the examples. I wish that I covered a particular all the areas, and inshallah in our classes you are going to have all the details, even slope and deflection. I wish all of you enjoyed with me. Any type of questions and answers, I am ready for all of you. I wish all of you enjoyed as much as I can, and inshallah we'll be good prepared for the next class. And any questions for answers, I am willing to answer any type of questions now. Guys, question please. Are you happy with this class? You okay? Some knowledge you gain? Huh? Hi. Hello, guys. Yes or no? Yes or no? Huh? Tell me. Yes, the first question. Yes. Moment portion is not clear. Okay, I will explain it right now again. Again. No problems. Let us see. See, guys, now you have portion side of beam. Okay, so you have a particular beam. This is a beam you have. You have a beam in this, see? Due to this load, see, this load, B, for any, and you have here support. And you have here another support. For sure, 100%, due to this load, this beam, it will take this direction. Okay, take this direction means what here? This section here. I have this section now. I have reaction at the R1, and they have another reaction R2. Okay, this lower fiber in this section, tension or compression. This is a section. Lower fiber is in tension here, and here is compression. Tension, compression. And upper fiber in tension. صح؟ Lower fiber in compression. Why this section have lower fiber in tension? Because this reaction giving moment in this direction. See. Oh, yes. Put your finger here. Where is the moment coming? Coming from the right hand side, coming from R1. You buy R1 multiply distance. We call it X1. Assume X1. You buy R1, X1. In the left hand side, you buy R2 minus R2 multiply X2. This is X2. Why minus? Why positive? Sorry, positive. Why positive? Because tension in lower fiber. This reaction, it will come. See? Where is the tail of the arrow? This is the tail of the arrow. That meaning this is the side of the tension, lower fiber. But this is positive. Any force will make the lower fiber in tension for a particular section. That's meaning what? This is positive moment. Reverse of it, you have a particular section and you have another beam in this direction. You have a load in this direction. This is your load P1. So that's meaning what? Reaction here R1, and you have another reaction here R2. This reaction make movement in this direction. Upper fiber in tension now. Upper fiber in tension. Lower fiber in compression. This moment is negative moment. R multiply X1, this is X, you buy X1, you buy R1 multiply X1 is negative because the tension. This is the way, is the simplest way you can technique. There is clockwise, counterclockwise, blah, 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 but this is the most easy and simplest way you are going to define, positive or negative. Okay. We will make it in color next time. It other like red, etc. We cannot see where it's going. Okay. I will take this one in consideration and we'll make it in color later, inshallah. Again, guys. Something wrong. I will make it inshallah next time in next classes in a color. Okay, let's us go for question and please raise a hand. Guys.
Yeah, Mr. Nazir, you can talk.
Talk, please.
Yes, Assalamu alaikum.
Alaikum assalam wa rahmatullahi wa barakatuh.
Yeah, it's had been nice class. It's good. It's good. We got us a lot of points. So, sir, that's my question. In this UPDA, how many questions will come in this structure?
From 3 to 5 questions.
3 to 5 questions, no? Okay. So most of them are problematic, right?
Yeah, most of them, correct. Most of them, yes.
Okay. So the next class will be for the structure, or you will be changed?
Once we start the batch, we are going to have the first class is as introduction. After the introduction, it will be 10 classes. Introduction is not included. And we are going to start with structure analysis. Maybe we are going to take 6 hours to 9 hours for structure analysis, because the structure analysis is confusion topics, and once you have a confidence as much you can solve by your hand, it will give you a confidence, a strength, and this is what you needed in your exam to feel a confidence.
Okay, sir. Thanks. Appreciate it, sir. Thank you very much. So the class will be on web series, or we have to attend in your classroom training class?
I believe this is with Green International, and Mr. Ravi will schedule, if you are enrolled, it will be scheduled soon, as much, inshallah, within a week or 10 days, it will be scheduled for the coming batch.
Inshallah. Thanks a lot, sir. Thanks a lot.
The next class will be starting on 16.
16. So this batch will be on online, or we have to come there in your classroom?
Yes, 16 June. This month virtual only. I think we up to end of July, we need to do virtual training only. In September only, we can.
Okay, please notify before.
For face-to-face.
Don't worry, you are going to enjoy it.
Yes, sure.
Yes, please, before the class, give us notification, right?
Okay.
Sure. Yeah.
Okay, sir. Thank you, sir. Thank you. Thanks a lot.
Most welcome.
Okay, next question, please.
Hello, guys. Okay. Yeah, there is two. Yes, please. Yes. Raise the hand or whatever. There is two guys. Raise the hands now.
Hello.
Yeah, Mr. Sakisha, you can talk.
Yes, sir. You can hear me, yeah. Sir,
Yes, I can hear you.
Yes. Sir, I want to ask you, these sections which we finishing.
I cannot hear you again. Please repeat. Hello.
Hello, I think his internet is not clear. Not Cantilever. Saksha.
Hello.
Hello.
Your voice is breaking.
Yeah. Sir, what I'm asking, whatever just now we listen all the class, we have recording, no? Can you please forward us in our email or in WhatsApp anywhere, sir? so that we can revise once again the class which we have finished.
You mean
okay.
keyword for
This
the-
recording.
keyword for the-
Hello?
Again, you mean the schedule for the classes?
No. This class which we finished now, just now.
Okay.
Yeah, we already recorded this, right? Can you
Ah, of course, yes. I believe Ravi, it will be
Yes, yes,
shared.
you will receive it. You will receive. Yeah, this recording will be sent to you tomorrow morning. Not only for you, for all the registrants.
It's clear
This
now?
video recording will be sent to you.
Can you hear me, sir?
Clear? Yes, yes,
Yes,
yes.
I heard you. We are going to share for all participants all the recording video now. Whatever recorded, we will share it with all of you.
Yeah, please share, sir, so that once we check, if you have any doubts, how we can contact to whom we need to contact if you have any doubt.
We have Green International, all the data and information, all the mobiles and WhatsApp. You can contact them for
Okay.
enrolled
No.
for next batch, inshallah.
Yeah, we already enrolled, sir. What I'm asking, sir, if you have any doubts, how to contact in
Okay,
class
you
is
have.
finished.
We are going to create one WhatsApp group for sure. Once we start our batch, we are going to create one WhatsApp group for the batch, and any questions and answer we are going to share it, and we are going to share a lot of questions and answers, homework, exercise, and you can any doubts we can clear it in the WhatsApp group. Okay.
Any more questions, please?
Okay.
Any more questions? Srinivas?
I believe they are happy now. Okay, guys, we will soon, inshallah, we'll start the Ravi in 16.
Yeah, 16 years.
Okay. I wish all of you, inshallah, to enjoy our classes. And for sure, 100% you are going a lot. I am guarantee this one. And we are going to have a very interesting classes, and we are going to have fun, inshallah. I wish all the best for all of you. And thank you very much for attending our webinar today. And let us meet, inshallah, 16th of June. Okay, guys? The internet.
Okay, thank you, guys. Let's close the session.
Okay, Ravi.